Okay, I believe that you're all here, so can we start? Do you agree? Okay, my name is Pavel Dakic and I'm gonna speak today about the topic called Microservices and Containers. The idea is to present you some of new stuff. Maybe you already know this, maybe not, but I'll try my best to get better with this topic that you have much better sense about what this is about. So here we're going to cover evaluation about computing, historical timelines, also challenges in the matrix of microservices, what are containerization processes, what is a container, and so on. Also, the part for your questions is going to be in the end. First, as you know already, you have on this slide presented current status of the infrastructure and computing. So first one is deployment process, which you already know and use. It's a CI/CD pipeline and DevOps. So this is like idea which we would like to use today. But previously it was here, as is shown here, is waterfall, agile, and that was before this happened. And when it comes to application architecture, we had monolith, NT, and microservices, which I use today most often. And then we have the part which is third in the line, deployment and packaging. It's like physical server, virtual servers, and containers, which are used broadly today. Also, the application infrastructure is stayed the same, is data centers. Mostly some of your services are hosted or cloud-based, depends on your services which you are using. So what is the history about this and the evaluation which we had previously? This is what is happening here, as you see, from early 2000s until today. So we have monoliths, they are still here in certain services, certain companies. They are still used, and there is a reason why they're still used, because they are very complex, very hard to maintain, and also very hard to progress in this microservices world. The second is slow changing infrastructure that's like simply in between the monoliths and microservices. Then you have loosely coupled on the right, rapidly updated, and small servers like small companies. And also on another side is big servers, which are doing this the same. Then what are the challenges by using this? The main challenge is, of course, the deployment, testing QA, production, scaling out all these services. That's the reason in the first place why we have decided, or some of the companies have decided to use microservices. So always is the problem that we have the uniform infrastructure, virtual machines, and the same infrastructure when we are doing the development. So the clusters and the data centers, disaster recoveries, the data has certain complexities which we need to cover. So in production, if, or let's say, for example, some of you are using Macintosh, and on your side is working, but when you push it to the container side or to the cluster itself, it's not working for some reason. And in order to solve this, the possibility of doing this is to use containers and some other approaches. Before we get to the side of containers, I will quickly just show you what is the current status about the history of the containers when they started. The first idea I had from Unix side, from version 7. It was a very long period of time, and I will focus mostly here on the Docker side. I will not go in detail because it's boring history. My idea is to come to the side of trying to show you this directly on the examples. So when someone mentions containers, we always see this as an octopus or very complex task that we need to manage the containers, to deploy them, to ship them, to create certain infrastructures. And all of this stuff is really hard to do. But if you have the right tools and the knowledge, it's not so hard to do it. So why to use containers? What they are? The containers are like small-based operating systems in a way that you can scale out the small infrastructure, and you are able to spin out all the information in small libraries. So you have small informational system or operating system with all the libraries in one place. Also, it's a lightweight. It is easy to copy and paste in high availability structures, and so on. So containers are available on any infrastructure, which is not the case on the virtual machines, which is very heavy on the weight of the file and everything. Also, they are more resource predictable. You can use more resources in the clusters, and they're more efficient, but of course, and it's always depending on the scaling and the needs which you have in your system's architecture. Also, containers, we can be saying that they are like small computing units which are utilizing some parts of our cloud-native applications. This all depends on your needs. How we use containers depends, of course. There are certain currently informational systems out there like Netflix, Amazon Prime, and some others. So we have like static websites which are using containers to produce the containers. Then we have front end, back end, user DBs, and basically we can use them and scale them everywhere. From your computer to big scale, to say structures and servers, we are able to use them. When to use them and when not to use them, that's a constant struggle. That's something which depends again on your system. If you have like distributed system, clients, users like Netflix, in that case, I would advise you to use microservices. But if you have like banks which are stable, then it's maybe better to consider to use a monolith. We can discuss about this. If you have questions, write them down and we can have a discussion about it. But the reason is that they are able to be very quickly deployed. They have all the stuff which you need. You don't need to spend a lot of time in fixing the bugs in the operating system like it's on the virtual machines. Also, they are bundling all the stuff in one container, one configuration file, and you are easy and ready to go. Also, they're isolated. What this means? This means that you're able to create certain processes without interference on your host systems. Also, they are used for testing purposes, for security purposes. Let's say you have some kind of viruses and you would like to test out certain code. This is also the best possible scenario to do it. Also, on other layers, it is common to use and to share binaries, libraries, operating system, and also you can share certain aspects in other containers. So how this looks like. This is the image which you can see on the left side. Number one is currently the virtual machines, and the second is the container side. They are not the same as is the first here written. Container are not the same as virtual machines. They're isolated and they have shared OS, and of course, again, depends on your use cases. So how this looks like in the aspects of the microservices. You have, let's say, APIs, and you start from, let's say, if you use Discord, most of you are using Discord today. You have some kind of chat or application which is written in certain language, and you need to have some kind of API or communication channel. In that sense, because of your communication channels are distributed and there is a lot of users on that network, you need to have microservice which is going to collect the data, process the data, and get the feedback to the user. Then you have the databases on the second step. And the third one is like the code which is running in the background. This can be your containers, it can be some services, dashboards. All this depends on your idea. This is like boilerplate of most of the applications in the containers. You have a database, you have a code, and the shared operating system which is able to run this information seamlessly. Then the fourth step is like you're running certain services. It can be Redis, storing, caching the values, depends what you want to create. But most of the times you have some kind of cache of the databases. That's the fourth step. Then you have the fifth step is some kind of SQL files which are inside of your container and microservice together bundled up. And the reason is that you need to create a backup from this. And also this can be centrally located information about your databases. How this looks like from the perspective of developers and IT operations. So on the left side, you have building processes. So you as a developer, you are able to process certain information to connect to the server, but of course you need to have certain open SSH keys in order to run these containers on the cloud. And there is like IT operations, where you scale, deploy, manage all this infrastructure information. It can be on-premise, and it can be also on cloud-based systems. So again, what are the benefits and why you should use the containers? Benefits is they are able to help the teams in agility, and that you have all the same version about your structure and the code which you're using, so that you don't have like problems in using different virtual machines, operating systems. And let's say for some of you which managed to learn Java and object-oriented programming, you managed to see that there is a problem when you spin up the Java code on Mac and when you spin up the code on Windows and Linux, mainly because of the libraries which needs to be changed depending on the system which you are running. Also, agility is coming from the Docker engine, because as I said today, I'm gonna focus today on Docker. There are others also possibilities to use containers like LDX, and some mostly used in Terraform world, but I will not go in that regard. So they are simple tools. They have universal packaging. They also are very good because of the speed, because all of us like speed and possibility to spin up whatever you would like to use. Also, we can quickly isolate certain structures. For example, some of the services are not functioning correctly. There is a case of Netflix. Some of their services were not working correctly. What that means, let's say in the US and let's say in Europe, you have certain aspects of the services which are provided in certain regions. And it happened that they pushed the code directly to that part of the world, but the code was not fully functional. It was like reloading the page constantly. So what they decided to do, they decided to just shut down the service for that region, and that is possible when you have the microservices. But this is not possible when you have the virtual machines which are like distributed, and it's very hard to do it in that way, because virtual machines require a lot of time to run, to boot, and to get in shape, and that you are able to maintain all that infrastructure. So that's one of the possibilities which can be utilized by containers. Then also the efficiency is that you are able to share the machine's kernels. So you are able to scale and utilize the clusters and their performances, because most of the times the cluster itself is not utilized sufficiently enough. That's the reason why we have the cloud infrastructure today, because cloud infrastructure used in, let's say, Google, Microsoft, AWS, and other clouds were not used by their own purposes, so they decided to create a plan which we are using today, so that they can utilize the power, the costs of the storing servers and everything. And also there is a reason why everyone is deciding today to use the containers. You are able to create certain layers, and that you can create this information in one ecosystem. Then there is ease of management. This can be sometimes easy if it's a small system, but also it can be very complex, depends on your structure and your architect ideas. And also the possibility of automation when you are doing CI/CD pipelines is something which everyone likes today to utilize. Also, when we speak about communication and clusters and the cloud infrastructure, we need to cover the security. They have all the features possible to be directly run in the small containers, which is not the case in the virtual machines and the fully standardized operating system. You have to have certain antiviruses, and here you can run this in the CI/CD pipeline and get this information quickly. Then we come to the point of open standards and types of containerization. The reason why the community decided that this needs to be standardized in the way that we can use this on any platform. So they decided, based on the solutions and container-based, that they would like to create some kind of structure and initiative. So they created the Open Container Initiative called OCI. This stands by their perspective possibilities and standards how to utilize containers on any platform which is out there. They established this in June 2015, and it's for Docker and all other industries which are using this in this sense. This is their website, which you can see here. This is like initiative. There is standardized information explained how you can utilize this and how all the cloud providers should comply and be like open to utilize this. So if you would like to visit, you have here on the slide link. So what they are promoting? They're promoting common minimal standards and specification, which all of the containers used by different cloud infrastructures, but this is in the regard of the Docker and LDX or other types of engines for spinning up the containers. So the user will not be locked in a certain ecosystem because, for example, you like Docker, but you don't like it for certain features of the networks, or there are features in other technologies which are providing you certain features which are not available, and so on. Also, they would like to take possibilities of certification in this world, so that you have like possibility to say in the companies, I know what is open infrastructure, what is OCI, and so on. Also, software companies, depending on the scale, but on most of them which are trying to use this, are thinking about microservices as a good approach, considering they used in the past the monolith, and it takes a lot of time to get the fully functional product. And that's true, but in the microservices world, you are able to very quickly get the fully functional application running. I'm gonna try if I'm gonna get the time to do it today. If not, you can get the presentation and do it by yourself. But I hope that I'm gonna be effective and get in the time. Also, the microservices are being used because of the HTTP requests and the possibilities, as I said, for Netflix. Because you can stream the services, you can use your APIs, and there is a lot of scenarios and possibilities to utilize them. The concept, as you managed to see today and to hear, are not new, and they are mainly, I think, in most of the deployment services and deployments of the software. I am not sure that there is a company today which is not considering the microservices, and also they are transforming the way how we create the software infrastructure and the structure of the software itself, because you are able to create small prototype and to get this fully functional to present it. And also, microservices can work together. That means that you can use PHP, you can use different technologies in one ecosystem, and they're independent. They're not having a problem like you have currently on virtual machines. That means that if you, let's say, install Python version 3.7 and you would like to install a newer version, you're going to have a problem because they are not compatible, and so on. So that's one of the reasons why you use containers. How this looks like and why this is important. This is like cloud service providers. You have multiple cloud service providers which are enabling you to use these scaling possibilities. And the reason for this is we are using today internet like normal thing, nothing that is not existing today. So we have got used to it, to possibility that we can spin out all the containers today. From my experience, you can run containers from your phone. It was like one meeting which was interesting in working in telecom. We had like communication and challenge. Can you run your containers and the application framework by phone? Android, iOS, it depends what you have as your daily driver. So we managed to prove that it's possible to run. If you have the right codes and CLI, you can basically use any tool or any device to spin up your containers. And here is demonstrated on this image. You can see that you as a client, you can use multi-tenancy or multi-tenant cloud to provide certain services. Because, as I said, certain cloud providers has certain features, certain possibilities, and you can utilize depending on your use cases. And also the knowledge depends on your knowledge. Then when we come to the microservices and containerization, and that part of the reasons why you are doing this is you can quickly use them, and the cloud infrastructure has the possibility to scale out your computing resources, capacities, infrastructures as leading requirements change. This means you started, let's say, on small application, Node.js and some React, because I know that you like all JavaScript world today, and you see that you don't need a lot of resources to run this. You can run it on your machine. But let's say you distributed this application to the cloud and started working this, and you see that there is like 1,000 users in a second visiting your website, and that the resources are not sufficiently providing the efficiency, the speed, and everything. You can just go to the cloud, Scale out. So when it comes to the part of the scaling, you have two types of scaling. You have horizontal scaling, vertical scaling. So here is demonstrating what this means. Horizontal scaling means that you can add more containers, more instances, and you can distribute them on multi-clouds. All this is coming to the end that you need to understand very good network infrastructure and protocols. And then you have vertical scaling regarding RAM, CPU, and other resources that you can get the speed quickly. What the multi-tenancy or cloud providers are trying to do is they try always to give you the best possible offers and to give like software as a service, and that you have the latest technology which is out there. Also, this is bringing you not only traditional possibilities of today what is available there, but also possibilities of learning new stuff, and also the security is one of the key aspects when you're doing this. Here is an example from Azure perspective for distributing Azure Kubernetes. What is Kubernetes? Kubernetes is a cluster. That means that you have multiple microservices running in their structure. I will not go into detail what here is exactly about their tools, functions, technologies. This is like just explanation how this is functioning. So you have a DevOps. That's a DevOps engineer which is creating your pipelines, creating the process, and then you have like client application which is running out there and utilizing all of this stuff together. Again, security is very hard to do in these environments. Why? Because when you add containers, you increase the level of security which you need to keep track of. So if your container is affected, you will need to have a way to find that container and to see what is happening. Most of the times for this occasion, developers of cloud services and microservices and containers are utilizing dashboards like Grafana, Prometheus to keep track about all of this stuff together. Because the breach can occur in one container or across certain infrastructure containers. This depends on the versions of the cloud and depends on the version of the node or the technology which you're using. Because some of the features which are currently in the production can be older versions and newer versions needs to be tested. For example, this was one of the previous examples in the Linux namespaces that they had ability to create networking, mounting points, process IDs, and today we can see that the researchers are continuously working on finding the ways how to do it and how to protect it. Now we come to the interesting part. I hope that is going to be interesting for you also. It's a Docker side and it's widely used. Docker is both a company and also technology. They started to play with this in 2013, and they managed to get today very quickly to be usable on different platforms. So they are available on Linux, Windows, and Mac. And they are able to create software quickly than ever before. Also, they are using and utilizing possibilities of building, testing, and deploying application very quickly. By using Docker, you're able to package the containers. The reason of this image on the slide for shipping is you're basically creating a shipping dock where you're able to ship your containers to the cluster itself and the clouds, and there you can utilize all that possibilities. Why the Docker is so used and available is because there are possibilities to use CLI. And when you have CLI possibilities, you can use any platform to build, create, run, etc. And also, something which I like about Docker is possibility to create certain Docker files. And also, they have possibility to utilize various images and their Docker hubs and storing registry. And today, from my experience working with this technology, the Docker engine is very stable. Of course, it was not the case previously. So you have the key terms. It's a Docker engine, which is managing all the stuff. Then you have containers. That's like information about the image which you're going to use. And the registry is the image repository where you have all the information which you can use. Also, this the registry can be private because you are able to create your own images, because there are different reasons for creating specialized custom images. For example, in telecom for 5G or some other use cases where you need to cover the telecommunication of the infrastructure and the network, you need to create certain image which is able to be quickly deployed and utilized and tested. So some of the solutions out there are not available for now. So as I said, this can be locally inside of your premise environment or in the cloud. Depends on your idea of usage. How this is organized. You can see here that Docker has three key feature commands. First one is Docker run. That's for running the containers, then building the files, in the case if you have like a file. But the mostly used today is Docker pull. Docker pull, if you have the possibility to use Git, I believe that you all had the chance to do it. Because if you are here, then you, I believe, had the chance to do it. That is like for pulling the images. Then you have Docker daemon. That is inside of their engine. And in the case you manage to pull the image down to download it on your local machine, you can get Docker to spin up certain applications or technologies, depends on the use case. Here they demonstrated the usage of Python, Redis, and Alpine. And then you have here a container. Container is like your possibility to create small package which has inside a small chunk of the service, a small chunk of the OS, and possibility to communicate on the network level. And then on the registry side, as you see here, there are different images, and also there are new stuff today, extensions. Extensions in the world of Docker are enabling you to cover all this stuff, to check what is happening out there. Also, you have the plugins. That's additionally to extend the features of Docker. For everyone interested in this technology, you can download it on their website's location. It's docs.docker.com. You can download, as I said already, for different platforms. There is mostly used today is as Mac users like it to use it. It's today available to use it on the Mac. Previously it was not available. It was only available to be used by CLI, which is today much better. When we speak about the ecosystem, it's very huge. You have different parts of the infrastructure. So you have here, as you see, official repositories, deployment tools. You have also networking, clustering. So based on your ideas, you are able to create certain software architectures, which, for example, previously in monolith application would take, for example, small distributed application with, let's say, client, all this stuff, let's say 2 years or more. This is their Docker Hub. This is public registry of images. You are able to search any image which you need. I will not go in detail. It's basically simple as just writing the search term. Then what the Docker has here has multiple layers, and here is written on the right side on the Docker file example. This is how you can create your file. This is basic example to create and to install Python version on the CentOS version 7. Also here the small image, this blue one on my left, your right, is showing that you can utilize, as I said, multiple images. But of course, be careful when you do this, because you can create a lot of drags in a way that means that your containers are not running correctly. They are quietly slow, not efficient. So check them out, test them, and see what you can do in this sense. Then we have another command which is called Docker Compose. Docker Compose is enabling you to create and run your containers based on the file. As I said, you have two approaches. You have approach to just run the container using CLI directly by running existing images if they are created that way, and that is one of the ways to do it. Second is to use the Docker Compose. So how this looks like, how we are managing all this stuff. You have the image which you can see. you run the container, which is containing operating system, software, application code, and there is like a cluster. You see the image here. And there are different services for authentication, tracking what is happening in the cluster, databases, basically you name it, whatever you would like to use it. Why this is crucial and why you need to learn it if you would like to be in line with new technologies, because most of the companies are using DevOps technologies and also agile approaches, and they would like to be efficient. Like here is 8 steps to be efficient. So you need to plan, you need to code, and you need to build this application. And by using these technologies with Docker or any other type of the technologies out there for containers, you are able to do this very quickly. Then one thing for others which are interested in networking, and this is one of the risks of not able to do certain stuff, or if you don't understand how this technology is functioning. Docker itself has different bridge networks or possibilities to create the network itself. The reason for this, as I said, is that you can create certain clusters of your networks. So you can create small microservices or different services in different networks, so that you can make some isolations if you have like testing purposes, if you have staging, production. So for creating new networks, you can use this command down below. It's written in Bash. Most of the commands which you're going to utilize are possible to be run in any terminal, but I would prefer that you use Bash. So what this means is most of the students which are trying to utilize technologies is they are not able to access these containers outside of their network or outside of their container itself. So the trick for this is to understand what is the host port that is inside of the network itself and the container, and that's host port, which is written here, and it's written here like IP address, bridge, which you can see the container, and inside and outside. So if you would like to access the container in your machine or outside of your machine, you will need to like create a hole, like they say in security, in order that you are able to access the port 80, because the port 80 is mostly used for web services. So how this is functioning in the sense of sending the data. I will not go into detail because this can take a lot of time in explaining all the stuff, but I will just quickly explain this, that you have like sending side and receiving side. Sending side is your container and receiving side is your PC, and you have like all the network going from certain layers until it gets to your network cards, and then routering to the internet, and that's something which we can discuss in more detail. How we can adopt all these technologies? First, we need to understand it. That is one of the things. Second, we need to create a roadmap how we're going to do it, and also which technologies which are going to be used in this case. Because mostly today used are AWS, Google Cloud, and Azure. And all of them are great, but they are not always the great for our use case of software architecture which we are creating. Some of the features are very good in Azure because Azure is providing a lot of features, but sometimes it's very hard to configure it and create it that is in the line which you can use it. So the main question is always why you should use it, who is using this? Based on the research done by the Docker organization, they're saying that the most times when the technology which they created is used in deployment, continuous integration, DevOps, and also which is important to create new technologies based on the monoliths which are out there. Because monoliths are very hard to maintain. For example, for social assurance, they use very old technologies, old languages, and as you know, everything is changing. There are not so many developers which are able to do it in this way. So they're trying to prevent this, that their infrastructure is going to be sooner or later stopping because they don't have sufficiently knowledgeable people. So they're trying to create these infrastructures to migrate all the information to cloud, but always consider, is this the best option when you create your software architecture? Is maybe this better to be created inside on your premise? That's the reason why your application modernization and portability are also key to consider. Maybe it's best way to have a hybrid solution, that certain solutions are available only in your premises or certain solutions for clients are available on cloud. The main concern is the data, as always. Why containers? Why not something else, like APIs and virtual machines? Main reason is we are trying to eliminate compatibility issues, also to improve the speed of releases and to create a life cycle of the application and software more efficient. Then also the proving resiliency. And if you are on the same page, it's very easy and efficient to do it. If you're not, then it's very hard to do it. Also, good uses is for testing, creating certain stuff. When you, let's say, create idea and you would like to show this to a client, then this is the best possible case to do it. And another way to do server density is to utilize certain dynamic ports, because when you use the VM, it's very hard to scale it out. The VM needs to be turned off in order to be maintained, but the container can switch and be used in a way that you are having the possibility, like using technology round robin, to switch from one container to another container. Of course, it's possible to utilize this in the virtual machines, but it's not so efficiently done in this sense. I'll not go in much detail regarding the good uses of this. I think that is clear. And then we come to the technology of deploying the stuff to the cluster. There is a technology called OpenShift created by Red Hat in this sense. But there is another technology called Red Hat, my bad, which is used in the Microsoft world. This is enabling you that you can create your cluster by using Git repository. So you can spin up any machine, any cluster, and you're quickly doing this stuff. The main reason for doing this is that this technology is universal. What this means, you're not stuck to one container, one technology. For example, if you use Terraform, you're stuck to one ecosystem, and you need to learn the Terraform very extensively. But if you, let's say, use OpenShift and CLI, you're not stuck. You can use and utilize this efficiently. The main reason for using OpenShift is you can use this as self-service. This means that you can install this on your local machine to test this stuff locally. Also, as I said, automation, collaboration, it's open source, standardized, and also it's possible to be used in enterprise businesses. Red Hat had this opportunity to create all this stuff together, so you have like variances of OpenShift in all of this information together. What is beneficial for you is that you can utilize all of this stuff by using these links. So I would suggest that you try Azure, for example, because Stuba has $100 or $2,100, something like this, as possibility to utilize, and also others, IBM Cloud, Oracle Cloud, and I think this is very interesting. And any questions before we come to the part of practical stuff? Anyone? No questions? Really? Feel free to ask. First row, anyone? What do you think? Any questions? What do you think? Then maybe better question for you. What do you think about the technology itself? Did you manage to use it? Are you using this technology in your daily business? Yes, no? What do you say? Anyone, please? Say.
Yes, we use it.
And how you are familiar with it? What is the depth of the technology which you are using today? Can you tell me? I'm just curious in a way what we are doing today in the software architecture.
We have Azure pipelines with Kubernetes.
Okay. And do you like it or you hate it to do it?
It's really complex.
Okay, what is the mostly challenging or the hardest part for you to understand? Maybe I can help you.
It's just really complex. A lot of scripts.
Scripts, and do you have maybe tools? Are you working in the company or it's your personal
It's complex.
company? Okay. So that means that you managed to get familiar in this sense. Okay. Any bugs like Docker is not functioning?
Personal.
Okay. And what are you using for deployment? Macs, Windows, Linux? Is that your daily driver for deployment application, creating application?
I have Windows.
Oh, okay. So we are safe in a way. Would you add something to my presentation today?
It was nice.
Okay, thank you. Let's hear on the left side. Anyone, please. First row, second row on my left. Anyone, please. Last rows. What did you manage to see and to hear? Yes.
What do you think is the future of containerization?
The question was, what is the future of containerization? I would say we are going to the end in a way of monoliths, but also we are adding maybe unnecessary complexity. Definitely the technology is going to be there, but I think that this needs to be changed. And the reason for this is when you start to create infrastructure based on the microservices and the containers, you are having then a problem to keep track about this, how long it takes to spin up the containers, how big the cluster is, where are the containers, which container is not working. So the question is better to say, will this technology be able to sustain ourselves if we just switch totally on microservices and leave out the microservices only without the monoliths? So my thinking and idea for the future is that we're going to have some kind of mix between monoliths and microservices until we get some new technologies. Do you have any other questions?
I just wanted to ask if you don't think that the containers or the containerized applications, like if you reuse them,
Okay.
they're quite hard to debug if something is working.
Mm-hmm.
At least it was for me personally. Like,
That's correct.
it was sometimes just like a black box I used.
The way to debug, to help you in this regard, which you are saying that you have problem for debugging the containerized application, everything, only way to do it is through CI/CD pipelines and creating security checks and linting processes. But I agree with you totally. That is very, how my colleagues say in telecom, hell. Microservices from hell. The main reason is sometimes it is working perfectly, you enjoy it, and it's very quick, efficient, and is doing the stuff which needs to be doing. But there are occasions when you need to debug network side, there are ports which are not functioning, you cannot reach the service, and you cannot find what is the reason for not functioning correctly. So some of the ways which I have deployed by doing the software architect role is to create pull plugs. That means you try to detect some of the containers that are not working. And then you just try to create separate structures of networks, and then you pull all that containers to separate network. When you pull them, then you are able to, let's say this one container which is running is possible to be checked. For example, for you to check what exactly you were having in the side of the container and the code. What was the foundation, what you had inside?
I don't remember it just a long time ago. I just remember I had issues with particular issues.
Mm-hmm.
Sometimes it was working perfectly, and sometimes I spent hours on Google trying to figure out
Mm-hmm.
the problem.
Was it maybe some kind of Python application? Because based on my experience, Python is quite problematic.
Yeah, I don't remember at all.
Okay. Well, it's nice to hear that you had the experience to see it. And did you manage to maybe think about architectures or software which you would use this technology and apply it directly in your case? Maybe for some home usage or some other usage in the company?
Well, I would definitely use it for if I need to scale my services. I think that's the perfect use case for synchronization and containerization. But I don't know, I didn't particularly enjoy developing the software.
Hmm. What was your main struggle by doing and using these technologies to deployment? Files, code, YAML?
YAML, I found it quite boring.
Why? Because of annotation or some other purposes?
Just like for me, the thinking about the code was taken out of developing the application like this.
Hmm.
It's just like I took some working stuff and just put them together.
And how many failed tests did you had by testing and running the YAML? That's always the case.
I don't know, a lot.
So most of the times it's around 30 to 50 occasions to get fully functional YAML code. And Git repositories, did you manage to use? Which kind of did you manage to use?
I didn't use it.
Any? Maybe CircleCI, GitLab, GitHub, Bitbucket.
We use GitLab.
Okay, then you're familiar with all of that stuff which they're using. Okay, thank you. Any other questions, ideas, problems? Maybe you have a problem in your job which you're not able to solve, and I can maybe show you how to solve it.
Maybe how much memory do you recommend for developing with
Oh, that's perfect. Perfect question. Wait, the question was how many or how much memory it's required for developer to use the Docker technology?
because I'm constantly running out of memory.
Okay. The minimum which I would advise is 64 gigabytes of RAM. Sorry, but that's the occasion. If you are thinking about creating infrastructure and software architecture in this case, I would advise you to create maybe some small server on Linux based and to create SSH and to run there all the containers. From my experience working in this area of containers, nothing is working on Windows and Mac. Only Linux based, that's all. Because I have deployed 100 containers on one machine, and just after a certain period of time, the service was okay, functional, working. Just Docker engine frozen, and I could not do anything. Basically, you need to do a power off, direct power off on the button, and that's all. So I would advise you to use 64 gigabytes RAM of RAM, but also when we are speaking about RAM, you need to use ECC, error correction memory. The reason for this is that you are constantly changing the memory, and that's a main challenge for the Docker. But the technology used on Macs is good, but it's not going to be creating possibility to scale. You can create files and ideas and everything, but from my experience, it's not fully functional for now. I believe that in the future it's going to be okay, because 2 years ago they didn't have the Docker engine on Mac side. Now they have it. It's okay. It works. But still, I would prefer to select a Linux-based system, Red Hat, paid version, enterprise version, and for, let's say, for your own purposes to play around, then 256 gigs would be more than sufficient.
But also for development machine, for example, when you are developing on laptop,
Yes.
it's quite hard to find laptop that has 64 more.
No, it's not. I can show you which has.
Okay, but in some price ranges.
Listen, when it comes to the microservices and the cloud infrastructure, it requires money. It requires investment. And I will tell you like this. All the companies which are considering using microservices and cloud systems, they have the budget for this. So when you apply for certain jobs, I don't know if you're working or not, working now? You're working, okay. If you decide to go for, let's say, telco base or oil company base, they have the budget for this. Because they need to scale, they need to be up to the date with the technology, and they will provide you the good machines. Okay, they will not provide the laptop, but if you request and if you have the cost centers for this, it depends on the country, of course, you can ask that they provide you a virtual machine and, let's say, some kind of server where you can directly remote to use a jump server or something like this, and to utilize this. So do not request a laptop which is having all of the features. Request that the laptop is stable and that you are able to install any system on your side. And then you are able to use this. I call this like they give you the secretary laptop, because you are in a way a secretary in that whole ecosystem, and you're able to scale this on the cloud because you are deploying that on the cloud. So I would advise you that you directly ask them, listen, give me the staging cluster, give me the staging server, or give me testing server that I am able to play around. Most of the times they have 4 server infrastructures or 4 types. One is production, second is staging. That's like between staging and production needs to be happening new features. Then you have testing, and then you have deployment server where you all try certain stuff, where you try to utilize it performances. This is how we were working in telecom and oil companies where I was working previously. I hope that I am managing to answer your question. Yes?
I would maybe add this. So basically you are advising to develop not locally, but develop on cloud, basically.
Yes.
And okay, but would you say that maybe microservices, Docker, containerization, and all this stuff has such a high price barrier to entry that it's basically, it boils down to the fact that go all in or don't go at all?
It can be that way. It can be, I would say, 50-50. Depends what exactly you are creating. What is the software architecture? Entry point is not high. The entry point is very small. It's, I would say, a fishing bait to get you in. But when you see the possibilities, then you see, oh, I need to scale. Like everything, they give you ice cream and you try it and you like it.
And it fails quickly, very quickly.
Yes.
And you are all in, basically.
Yeah, you have to do it if you decide to go that route. I will give you like this example. Netflix started with microservices, testing them in early stages while there were no one using and thinking about microservices. And I seen the improvements in their loads on the server, the infrastructure. And they were thinking about, should we use this or not? Then they see that their main cluster cannot contain all that information on monolith applications. What is the reason for this? The reason for this is you all are using the servers on your home, and you are living on different locations. And all these locations are utilizing certain latency latencycy you all, I think, had managed to play certain games, and you hate that the latency is what? High. What happens when the latency is high? Can you tell me?
It's unplayable, basically.
Okay, that's unplayable. And in that case, to solve that issue, it's like math about this, like a latency, what is the distance between the client. You are deploying the microservice, which is providing the service, but is not fully efficient. It's just pulling the data, caching the data, and to answer your question is you need to think bigger and to have the sense that this exists. And when you're gonna say, listen, no, we'll not go to monolith side, please. If you don't have like 1 million euros, is in a way, from my experience working on that projects, a minimum in order to deploy fully functional system. But we are speaking about millions a second requests to your APIs or whatever you're using. Always comes to the decision. You have certain patterns and reasons for making decisions, knowledge management, when you say, okay, we are going to the route of deployment only by monoliths or by only deploying by microservices. That's on you. Because if you are like an architect in the company, you are having the responsibility of designing this kind of stuff. That's the reason why you have this subject to say, okay, I have listened to your request. Let's try small and then scale like we have discussed now. To enter into the world of Docker, to create small application. Is this functional? Okay, let's try to scale this out to deploy it to multiple users.
Okay. Then maybe my other question would be that even on a small scale, I'm not a very experienced Docker user or container user. When I was learning it,
Okay.
I wanted to get there. But basically what discouraged me the most from learning, and this is maybe my mistake, that's why I may be asking, is the fact that I am using Windows my whole life. When I started developing and I started looking into Docker, I didn't know that Windows was basically unusable in this regard, and nobody basically told me. And,
Okay.
the fact that I quickly learned the hard way that I wasn't even able to install Docker and not at all manage it.
What was the main issue on your side? VSL2 or some
yes,
other?
I think, yeah, or Hyper or some
Hypervisors.
I don't remember exactly, but there were lots of mistakes and problems or mistakes, maybe even mistakes. But it discouraged me. And if I consider myself an average user who just starts learning and wants to know what this technology is about, and it discouraged me, then I can maybe assume that it happened to more people. Would you maybe say that these disclaimers or these limitations should be better described on their kind of website or some learning materials?
I agree. That's the reason why I'm supervising topics on bachelor thesis and master thesis in this regard, creating the tools and creating possibilities to getting easier in this area of DevOps, Dockers, infrastructures, decision-making processes, and all of this stuff. So I agree with you. Yes, definitely yes. They are hiding this, but there is a reason for this. They are hiding this because they don't like, or not to say they don't like. They would like to get a bigger company or big fish, to say it this way. Like the octopus, which I have shown today on their image that is showing like they're managing all the containers. They would like to get some kind of octopus organization of the company, which is understanding the scale and the complexities, and also which is willing to invest the money and the time and the skills for deploying engineers. From my experience working with developers or junior DevOps engineers, it is, as you said, very tricky to get started and to understand the complexities because you have all of this stuff and you don't know from which point to start. You need to have someone to direct you and say, okay, we are doing this now, and to explain you why we are doing this. What is the reason to start from this and not from that? Why we are doing now from CLI? Why we're not using Docker engine? And you're going to have a lot of questions, but my idea for this is, I'm trying my best, is to create a tool possibility by using a PIBA. It's an approach which is engaging you and creating certain lessons where you're able to go through the process. So there are certain materials out there, but they're not available to the general public. You need to pay for them. And you need to be invited. And also I was working in Microsoft as a trainer and consultant. There are tools and materials, but you will need to know that they exist in the first place. But I would like to create open source materials. Some of them are already existing out there. There is called YAML tool, which is like creating you a scenario lessons. So you start small. You start from creating pipeline. That's first, which you need to understand. What is a pipeline? What is a stage? What is possible? What is not possible? Which kind of tests you can run? Where you're adding stuff? As the colleague said, YAML side is very problematic if you miss, let's say, indentation. It's similar to Python. You have a lot of problems, and you just start thinking like, looking on the code, this is not functional, and you're waiting, basically waiting for something. On Windows is like waiting for updates. Here is waiting for DevOps to start or to finish. So I hope that I managed to answer your question.
Yes, you did. And this is exactly what I was asking. And maybe another problem which came to my mind while we were answering the question is that maybe the fact that I see a lot of points where a new company or startup or learner he comes to a point where it is really easily for him to waste a lot of time he spent just to see that it was all for nothing and he needs to invest or
more.
Completely reorganize his structure of equipment or something like that. And the best course of action would be for him to either invest a serious amount of money into it and do it really hard, or basically abandon the technology and scrap it and try to find some other way.
Yeah, but as for everything, without the right tools, you're not able to start. As your colleague asked, you cannot start Docker unless you have decent amount of RAM. So to test this, 64, it's like today a minimum. Also, when you start running VS Code, running Visual Studio, a lot of this kind of stuff popping up and creating complexity, you need to have the RAM. And also, as you know already, Windows 10, even now, Windows 11 is taking even more RAM memory. So we are just going up with the usage of the RAM. I hope that you are interested. Yes, say. Thank you.
But the computing power on cloud isn't that
Yeah.
you can start by 100 here and you can
Yes, that's something which I have told you today here. That's here available to you. You have a possibility to test this out. But the question from their side was for local deployment on premise. That was their question, if I understood correctly. That was the question. Yes, for development on your premise side, or as you as a developer, what to use, if I'm not wrong. So yes, that's correct. As you're saying now that you can use PinUp. Azure has for US students 200. All others, I think they have 100 or more. Depends how you create. No, it's a good idea, but you need to know what is the limit. What is the limit? How much you can push on your local laptop? Some of the clusters you cannot deploy on your machine. There is a limit on your laptop which is able to process. It's a limit about the networks, the motherboard, and all of that stuff which is only available on real servers, directly available on the data centers. Okay. Okay, thank you. Any other questions? Okay, can we have a 10 minutes break and we're gonna return and work on demonstrating quickly some examples of running Docker and just showing you this stuff for everyone which are not familiar in this. Is this okay? See you in 10 minutes. That's 3 and 16, okay? Okay, can we continue? Everyone back? Okay. The next part and my idea for this is, if you would like to follow, you can, if you have laptops here, is to try to demonstrate certain containers and certain microservices which are possible to be successfully deployed and created very quickly. So first I will just show you some of the mostly used container CLI commands. Some of them are pulling images, containers, and here are the ports and all of this stuff. First, I will start with the first one, is to explain it. It's a Docker image. So this means that we are pulling certain images from the Docker hub. You can have the Docker account. It's not needed. You can have it. It's up to you. It is nice to have the Docker account in the cases if you are creating custom images in this regard. I'll not go in detail with this, but I will first go with showing the networks on my side, what I have the networks installed, what is possible to do. So I will go now in VS Code. Just for quickly demonstrating this, I'll just copy and paste because it's much easier for me, and I'll magnify if this is not visible. Just see, let's see how like that. You see this? Or should it be bigger? It's okay. So everything starts in software architecture from the network. If the network is not okay, or you have slow networks, servers, cards, everything, cables is bad, you have a decent problem which you need to fix. So here on my machine, I have only standard Docker networks. That's Bridge. Bridge is a network which is standard for Docker, which is combining your existing PC and the network which is inside of the closed container which you're using. Then you have the host and none. Of course, you can create additional networks, depends on your needs. As I demonstrate in my presentation, you create certain networks if you would like to isolate and create certain containers separately. Then, if I would like to, just a second. To see, oh my bad. I would like to see what is the configuration file of my network. This is the information. You have here the name of the bridge. Does this seem to you familiar? Should I magnify or, I don't know, I don't see from my side. Yes, okay, okay. What type of the file this is? The structure, I mean. JSON, yes, that's correct. So we have like a structure of JSON, which is showing the information. You have some kind of keys and information, and then we have the main config. We have config, you see here this information. Okay? I will go back quickly on my presentation to show you this information. Do you remember this? Which I shown you. So this means that here is presenting information about network, local bridge, and local network which you have in this regard. Okay? Then when you check down below, this means if this is internal, this is ingress. Anyone knows what is ingress? Yes? Say? Yeah. But what means in this sense here? Yes, inside, okay, but what means here? Ingress is like, can we say that this is a traffic? Do you agree? Okay. Ingress means that you have the traffic which is coming in from the outside and you need to handle it. There are certain ingress services which are managing your load. It can be round robin or it can be zero trust networks or something like this. Then you see here information about options. All of these options can be configured and created based on your needs. But for now, we don't care about this. I will just say enter. That's okay. And go back to the slide which I was showing. Sorry. Yes. First, for you to play around at home, I will show you the link. What is happening? I don't see it. For some reason, it is stuck. Docker. Oh, okay, we're gonna do it this way. For some reason, it's not fully functional. Okay, on my presentation, I believe that the professor will add the presentation on the website, so you will be able to get all this stuff. But I will explain for all of you which are starting here. You have the materials, like our colleague asked, you have some of the materials which are out there and you can utilize them. First is you have the possibility here to containerize application. But I will need to create a task for you to try to fly around at home, okay? So I will not do this task now. I'm gonna do something more advanced in a way. But I will show you that there is a possibility to create application just cloning the information. I hope that is much bigger now, okay? And this is the contents of that container. This is what it has inside. It has some kind of package JSON, README specification, SRC, that is a source code of some kind of application. And here is, depending on the platform which you're using, Windows or Mac, Linux, possibility to enter this, to run the container. This container is based on the image Alpine, as is written here. All the Docker Hub, all the images can be found here. When you go here and say explore, and let's say Alpine here. On the right, this should be big enough. You can see the possibility to pull this Alpine. How you pull the image? I'm gonna pull this image because I will need it. I'm gonna click here, copy, and just go in terminal and say, I don't know if I can magnify it. Okay, I can. This should be, or maybe to, let's do it this way. Is this way better? Yes? Okay, so you are able to pull the image just entering this command. Of course, in order to be able to run the Docker at first place, you need to have running Docker container here down below. If not, you're not able to do it. So this is for this part. Second is part regarding you would like to update that application, to test that application. This is which I will advise you, or which I would like to get the feedback from your side. Did you manage to try this at home? But now I'm gonna go directly to the details. I will go to some advanced step which maybe you will not find, or you will be finding, but will not be clear for you. I will start from the portainer. What is Portainer? Portainer is a container-based application which is enabling you to manage your Docker images and also to see all this stuff. So I'm gonna run this command here in the terminal. That's the first one. But while I wait to download this, I'll go here and say Portainer. Okay. There are two versions. There is a community version and business version. Because of demonstration purposes, I'm gonna use community version. Here you have the information, what is the Portainer. I'm gonna wait for a second to this to be loaded. Is it loaded? Yes, okay. Now when I'm done, I'm gonna go to extensions here and I write Portainer. Do you see it? Yes, no? If not, please say. Yes? Okay. I install a Portainer, and by installing this, I'm able to manage the cluster. For the colleague which have asked how to manage all this stuff, you can use this method. So you can create your machine on a Linux-based system, and then you're able to just go there and see what is happening. I'm gonna say get started. Maybe we'll need to magnify this. No. I hope this is much better to see. Okay, you see this? Sorry. So I have a local deployment, a local environment of Docker. Here I have only currently available 2 Docker containers because I was trying testing preparing for today. And also I have here 8 CPUs, 15 images, 3 volumes, and 60 gigabytes of RAM available for Docker. There are possibilities to specify how much RAM you will use for your container images. When I click here, I'll just unzoom it. I can see that currently on my stack there are no running containers, only images, containers, volumes, and also what is for you important to see, what colleague asked, is possibility to see stuff. And as we discussed today in the section of the questions, some of the stuff here are there, available, but are hidden. You need to know where to look at. Okay, so when I click here on the networks, I can see and I can show you again the information of different types of the networks. But here I'm having the possibility to change the network and to add new networks. Basically here you can have new network, name, what is the type of the network. You see here. I'm not gonna go now in the details about what is the type of the network. This is something which we can discuss later. But there is a possibility to do it here. Portainer, from my experience, is a nice tool. It's quick, it's easy, and the reason for using it is possibility to see certain stuff. But there is a problem in here. Which kind of problem? Problem is you have created all that configuration files, you have everything set it up, and you have a new machine, or you have a colleague which is just starting or moving from one PC to another PC, or whatever is the station. If it's a Mac, then a Macintosh. Then in that case, if you are moving from one structure to another, you would need to create certain volumes. Volumes is basically your virtual hard drive where you store the configurations, and you're able to access it directly here. I will not run it now because I have already this configured, but it's just simply running the line of the code. That is the reason of using these microservices and the containers in the first place. You have the flexibility and, of course, portability. You just run it. Of course, you can run this on your phone if you have CLI access. Okay. What has happened on your side? What's the problem?
I just connected to my VPN, it didn't work. Nothing to do with it.
Okay. Let's try this next one. Anyone knows what is light speed? No. Okay. Lightspeed is HTTP 3 protocol supporting web server. For example, you need to create some kind of web shop applications and you need to run it quickly, efficiently. Of course, there is Nginx, there is Apache, but for the most efficient and quick applications which are up to date with new technologies, I would advise you to use Lightspeed. I will now run the information here. There are two versions again, one for business, one is open source. So I will download these two images, okay, and I'm gonna run them in seconds. A second. So I'm running these commands. You see that images are being downloaded. Okay, is this part clear for you? Any questions? Okay, no. Then next is I'm gonna run the instance. Here I will explain quickly what this means here. There are two ports which we're gonna have for us, or in this occasion are three ports added. The P stands for ports. You have internal ports and external ports which you have inside of your cluster and on your machine. I need to publish ports which are used for managing this server and also AT port and SSL port 443. So I'm gonna run it now, but before I run it, I will show you that I don't have any containers here currently running, okay? Empty. Okay, let's try it. Run. Okay, I have now a trial license for 14 days because it's a business version. Okay. Need to wait. Of course, if you buy the license, you can deploy it to multiple cluster services depending on the utility which you have. Sometimes it takes time for running, but you get used to it quite soon. And also, while I wait here, funny story is when you run multiple times the same stuff, it can happen that you break it. That's one of the problems of caching which you have in my occasion. So, because I see that this is not working and I would not like to wait, so I will break this and try something else. Maybe I'll use OpenLight, maybe it's gonna work in that case. No, it's yesterday it was working perfectly. Let's see, maybe it's a container already running. Okay, it's running. It's here. Okay, running. So when I click on this link, you see localhost. Oh, it's running, you see? Proceed. Okay, it's 404 because we don't have anything. But it's just simple server. And for managing, the port is 780. Now, when you start, as always, you don't know what is the password. So in my presentation, I have added the information to see the information how this is functioning. But first, you will need to connect to your Docker container. What is happening now? Your application is running inside that container. It's not accessible directly to you like VM, like you have it normally. So in order to run it, you need to execute docker exec this here in bash. So I'm gonna go here. I think that I'm gonna need to open another terminal. Okay. Okay, now you see that I'm inside of the VM. Not the VM, but the container itself. But inside of this, you have a small part of the system. Is this clear for anyone? Any questions? Yes? Ask. Okay. Now I'm gonna go and see the files regarding the password. let's see the password of our service. And you see the admin password is this. You see? Admin. So I'm going to copy this. And I'm going to enter this just to show you admin. What I made the mistake. User password. Okay. Okay, doesn't matter now in the moment, but I think that you understand this concept. What is this about? I'm gonna exit from here. And next in line, which I would like to show you, which is maybe interesting for you, I will skip this, is creating database servers. Because sometimes you don't need to be installing all of this stuff locally. So for doing this, I'm gonna pull the image called MySQL. Again, I'm gonna go to the terminal. Okay, now I have the image. Next is I'm gonna run it. But first I will need to kill the container which I have here. Okay, now I have MySQL. I will magnify. You see the container? This is the container which is using the image MySQL latest. Currently it's running on these ports, as you see here. If I click, I will not get anything because it's not running web servers. But if I open, for example, Naviget, and let's say I have a connection, which is localhost, I'll magnify. You see, this is a connection. Now, what is happening in a moment? We are sharing the ports from the containers on our machine. We are connecting this directly together. I will just test it out now to log in, and then I'm going to stop the microservice and the container itself, and we're going to see that it's not working in the moment. Okay. So I have inside, as you can see, I hope that you can see, that is quite big enough. That's a database. Okay. Now I'm going to just quickly create new database. Sorry for making a fuzziness for you. Let's say test. Character set, it can be any you like. Let's say this one. Collation. It doesn't matter. Okay. And this is the database which you can utilize. The reason why I'm showing this is maybe on some other subjects you will need to create some kind of service, or you will like to test something, but you do not want to break the changes on your side, on your PC. That's one of the reasons. Now, what I'm going to do is I'm going to stop the service. I'm going to stop it here. And if I try again, let's close. Now it's showing, what is showing? Not possible to connect, okay? The same is for other services. Other services which I'm going to demonstrate. Next is MySQL Server, which is available in 2 versions. Many of you are maybe using this, maybe not. The process is the same. You just download the information. Now we come to the part for the memory. Here in this line, I hope this is big. It is. You can specify how much memory you would use. So containers have possibilities of specifying the parameters, but you need to read and learn the documentation. So I'm gonna go again and install Microsoft SQL Server. Again, here is nothing running. These are all the containers. I'm pulling the image. And now I'm gonna run this code. I'm not bored you with this because it takes a lot of time to understand it. Okay. Now it's saying that I already have the container. So, because I was testing it, I will delete it in a moment. And I will run it again. Anyone using MySQL Server in the daily driver? Anyone? No? Okay. Now in the Docker I have MS SQL instance, which is running on this port on the right, which you can see here. It's standard port, so I will now go and run Management Studio. Again, I'm gonna say that the location is localhost, and I'm gonna connect it. Also, for anyone which knows this technology, this Docker container has possibility to use the agent. So you are able to scale this up, to make replications, to distribute the databases, to do all the possibilities which you have on the regular servers. And also, there is a possibility to connect this to Windows Server, which has all the features together. Of course, every Docker container and microservice has certain limits. There are not possibilities that currently, in the moment, not all the features are available. So if I create a new database, test, okay. Here you go, this is the database. Now you can create the tables and you can connect to this and have it like it's locally installed. Again, I can demonstrate that if I stop the container, here you go, the container is here, and I stop it. And I try again, basically to create, let's say, create a table. Now it's going to start to break. Okay, but the idea is that you see that by using this Docker, how much time did I need to spin up this instance of SQL Server? 2 instances of different type of servers for databases. What do you think? 2 minutes? Okay, then question to you. How long you think it's necessary to install these 2 instances regular way on virtual machine? 30 minutes or more? Most of the times for MySQL you need at least 15 minutes to install. For MS SQL you need 30 minutes to configure all this stuff, to do it. So in this sense, this option is much better. Of course, as I said already, there are limits on containers because the system itself and the features which are available inside of the service of the container are not having all the features available for now. But I think that this is going to be changing in the future. So if I magnify here, what do you see here? That the connection is broken. Okay, I cannot communicate. Let's try this. So to spin up again the container. So this is my containers here. Okay, I'm gonna say okay now. And if I try this again, will work? It works. Okay. So what else I would like to show you is part for the networks. Of course, the same is now for connecting this to a network, but I will not go in details. I'm going to leave this, that you have something to work at home. That's the idea. To make you interested in this. I have another extension called Port Navigator. What Port Navigator is doing is showing you the information about the network you see here. And the reason why I'm using this extension in the first place is to be able to see what is happening in the background, and also that I can change the network to create isolations like I have demonstrated. For example, I can say here, this is only the container, this is the IP. I can change the ports, but if I change them, I need to restart the service. So if I say, okay, submit, now I am able to change the ports. I think that I have covered everything. Yes, I have covered everything, so we can go back to any questions. This is all from my side, which I was planning to do. Was it interesting or was it boring? I'm open to opinions. Thank you. Would you add something? Yes, you are. Yes, you are. You are the student. You maybe would like to hear and to see more, maybe which I didn't manage to show you, because as you know already, as you said today, this is a very complex topic. So maybe something you have, as we discussed, on your side, which we can maybe in the future add that in the future and show it. Do you have something like this? No questions, come on. Left side, no questions on left side? No? Okay, in that case, we can finish. I will leave you this slide. Okay, we can finish. If you would like to contact me or you need help with some kind of stuff or in your company, my email is here on the slide. So I hope to see you. Some maybe already know me, some we're gonna be interactive with me on next courses. So thank you for attending, for listening, and also for asking questions, and see you next time. Thank you. Bye.